Okay, so company's laptop, I should have brought mine. So, okay, all right. So hi everybody. So my name is Thibault. So I'm a lead engineer on Kong at Mashape, and I'm an OpenResty contributor. So we had some talk about OpenResty earlier, and we're gonna have some more. So I'm going to talk today about a Cassandra driver, so Apache Cassandra, the database for Lua and its evolution, because it's actually has like a little bit of story, so I thought it would be interesting and we could learn some lessons from that. So let's talk about Cassandra itself for a little bit. So Cassandra is a free and open source NoSQL database. It was created at Facebook, and it was published open source, released open source in 2008. And then Facebook kind of gave up on it, and it joined the Apache Foundation actually in 2009 as part of the incubator. And in 2010, it joined the Apache Foundation, the mainstream project. And it's been maintained ever since by the Apache Foundation. So use cases. Okay, so Cassandra is a decentralized database. So meaning that the nodes share the data, right? So you have replicas of the data so that if you lose a node, you can basically be tolerant to such failures, partition failures. So it has multi-data center support. So you can literally spawn such a cluster in one data center and another one in another data center so that you're geographically close to your data. Horizontal scalability is like a very big selling point of Cassandra is that the fact that if you want to handle twice the scale that you're currently handle, you just have to spawn double the number of nodes that you currently have, and that's a big reason behind its popularity among big companies, big deployments. So some people say it's like a key value meets column-oriented schema. So I know it sounds kind of weird. It has its own, its own way of modeling your data that kind of requires a lot of deserialization, and it's all of that is done via SQL, which is so like SQL, the structured query language, but SQL is the Cassandra query language. So it's somewhat. It has a kind of a learning curve, but it's going to be a database that's going to handle use cases for where distribution is required and scalability. So on the CAP theorem, the Cassandra kind of stands between availability and partition tolerance. So it's towards the AP side of things. And regarding consistency, Cassandra allows you to tune the consistency you want to use for each of your queries, so that you basically can do the trade-off yourself and choose where you stand in that trade-off, right? In the theorem. So then next, Kong. Just a little bit of history in these cases. So Kong is an API gateway microservices orchestration tool. So it's written on in Lua, so on top of OpenResty, and so the idea behind an API gateway is to factor to group together all the features that your multiple APIs, public or private, or your microservices can have, and rather gather them inside of Kong. But then you don't want Kong to be a single point of failure in your architecture either. So maybe that's why we're going to use Cassandra, because we also want to scale Kong as well. So started in 2014, and it's a free and open source project, at our community edition. And so if you want to hear more about Kong, Thijs, who came today too, is also going to talk about Kong, like more in details during his lightning talk at 4:45. So, okay, in terms of use cases, sorry for my drawing skills. So you have to think that. So if you have a microservices architecture and your microservices are replicated into multiple data centers, you want a way to have your data replicated across those data centers, and an easy way to do it is just to rely on Cassandra to do it, basically. So you can think of a load balancer and that is distributing your traffic across Kong nodes. And those Kong nodes talk to the local Cassandra data center to retrieve their configuration about where to proxy a request to an upstream service. So Kong really is a reverse load balancer, basically, a reverse proxy, sorry. And so here we have the way we replicate our infrastructure between different data centers is via Cassandra, basically. So all of those requirements are business requirements, basically. So Cassandra is for us a way to have multi-data center support out of the box, kind of. It's easy to scale, really compensates for the steep learning curve. So when you have in an enterprise the need for a deployment that's going to handle a lot of traffic, the learning curve from switching to Cassandra, if they don't already use it, is really compensated by the fact that once they use it, it's a easy to scale database, right? You can just, it's like I said, it's linear. You double the number of nodes, and you can basically handle twice as much traffic. Counters, which is a Cassandra feature that's just atomic counters that can be incremented to count things. So it's very useful for rate limiting, for just threatening the number of requests made to an API, kind of or the previous talk earlier. It was in Portuguese, so I'm not entirely sure I got all of it. But, and so it's also great for time series data, which is also a good coincidence because logging and monitoring is a huge part of maintaining your infrastructure around microservices and knowing how things perform across time, and what's the health of my requests and responses during that period of time or another period of time. So it's great. So the only thing is Kong is built in Lua, and we needed a pure Lua implementation because OpenResty requires you to use it's its own little world, like Hisham said earlier. So you need to behave like OpenResty wants you to behave. So it needs to be a pure Lua implementation. We cannot take an existing driver built in C and then just write the binding to it. That's just not going to work because we're going to have blocking I/O in the Nginx processes, and where there is no point in that because that would just kill the performance. So lucky for us, there existed LuaResty Cassandra back in the day. So LuaResty Cassandra was written by Juarez Boche, who started it in 2014. So it was written for Globo.com originally to handle for the streaming platform. So well, I'm not too familiar with it, but Juarez explains it in a blog post. And I don't know Globo too much, but basically they switched from Redis to Cassandra to support the streaming of like large sports events or national events. And we're using their MIT license, so great, we could use it for Kong. And some drawbacks were the fact that the library only supported the binary protocol v2, so we only support Cassandra 2. And today the mainstream version is Cassandra 3. But that was not yet the case back in the day. And the biggest drawback of all is that it's a library that's talking to a single node only. So the particularity in Cassandra is that everything related to that, the fact that the nodes, the peers are distributed means that you need to have load balancing policies on the client side. So you do not have a tool that's a proxy for Cassandra. Your driver, your client library is the load balancer and handles all of those policies, reconnection, retry policies, and keeps the health of your Cassandra cluster locally. So no support for that. It was just connect to a single node and then hope that node is up when you talk to it, and then yeah. So we started doing a few improvements. The first thing that we kind of struggled with was the difference between OpenResty and Lua, and we needed the framework to work in both environments back in the day. We needed it to work in plain Lua and for OpenResty, and that was a pain. So we're gonna get back to it later, but basically that was like our first hint that things were not gonna be so easy. Well, that thing should have been, you know, popping up, but since it's a PDF, because that didn't work. Yeah, the point is that the testing was not ideal either. You know, continuous integration was failing. It was just, it was, I don't want to say it was unmaintained, but it started to be a little bit unmaintained. So Jari's helped us implementing some of the things we needed, like batch support for Cassandra. So that's really good, because that's a very healthy feature to have for Cassandra for your clients, because it provides atomicity when you update your data. So thanks, Jari's. That was nice. And our best improvement yet to the library back in the day was implementing pagination support, because obviously you're dealing with you know, millions of rows eventually, and in Cassandra you need to iterate over them page by page basically. Otherwise, if you try to request all of them at once, you're going to have a lot of problems, both in terms of the impact performance on the cluster itself and on the application code. So yeah, but then after a while, we started not having a lot of not receiving a lot of love from Jari's. We contributed a binary protocol v3 I contributed a binary protocol v3 to be compatible with Cassandra 3. We needed it for Kong 2 because Cassandra started switching its mainstream stable release from 2 to 3. And our business requirements were all of these, and they were supposed to come up one by one, sorry. We want load balancing policies, which means we need cluster awareness, which means we also want retry policies so that we can retry failed queries. We wanted multi-data center support, SSL encryption, client authentication, and schema consensus, which is very useful when you make DDL queries. So when you actually define your create tables and everything. So you want to wait until all your nodes agree that this is the current state of your schema, and that was not supported because there is just no cluster awareness. So lua-cassandra, that's the fork that I started, and I felt super bad about it. But we just really needed all this to be done. So in May 2015, I just kept the marshallers, so everything that's related to the binary protocol itself, at least for V2, and started building on top of it. And so the goal was to have a data stack Slack driver for Lua. And I wanted it to be for Lua and OpenResty because, I don't know, I just thought it would be cool to also have it, you know, entirely compatible for Lua, and it would be a good thing for the community. Because we have drivers for Postgres, for MySQL, so why not for Cassandra? DataStax, like what that means is DataStax is a company behind commercializing Cassandra and enterprise solutions and builds drivers in Java, Python, C++. And so those drivers are very complete. They have a lot of features. They support cluster awareness. They have load balancing retry, reconnection policies. They support, of course, all versions of Cassandra. They have complete documentation. And so, yeah, I wanted interoperability between OpenResty and Lua for just, you know, everybody to be able to use it. So what this became is kind of 2 modules. I can't say I really made it yet. So we kind of have two modules now. So we have a single node module that is going to talk to just one node in your cluster. And again, if the node is down, then the connection is going to fail. Well, at least we have some nice improvements. We have automatic binary protocol selection between V4, V3, and V2 as fallbacks, right? So if you use Cassandra 3, you can directly use protocol V4, which has some more powerful features. You can, you know, tune the consistency slightly better for some queries. You have support for SSL connections and authentication, which is a big plus, right? So if you want to go to production with such a driver, because you have a Lua project that needs it, you probably want encryption and authentication. And so the cluster module is only compatible for OpenResty, and we're gonna come back to this, but it does really nice things, like, so it discovers the cluster of your the topology of your cluster. Sorry, it has auto-prepared statements. So the way you prepare a statement is you just pass a boolean to the function. You have schema consensus weight for the DDL queries and retry policies and load balancing policies, and so we have this Cassandra module, and then another namespace that is prefixed by Resty is our OpenResty only, but cluster module. So ideally, I kind of want to implement Cassandra cluster, which would be which raises some issues, but would basically be a Cassandra driver that supports clustering for pure Lua. But yeah, let's come back to it later. Yeah, just a few examples, I guess. So maybe you can see what it looks like. We have this is just a simple data definition query. So we just create a table, and so what we can see is we create a socket. We set the timer. We connect. At least we try to connect, right? If this is going to fail, so this is like the nice thing that Roberto talked about. We have two return values here. The first one is a boolean, the second one is a string. So automatically assert expects two arguments. So if the first argument is false, then the second one is going to be the string of the error. And because it's in assert, we're going to just fail, and we're going to see the error that actually triggered this. It's just a fast way to ensure that everything is correct. Like in a production application, I would probably write an actual error message with the error and like the correct stack trace, but stack level. So our result is a schema change, which means we change the schema of our database. And so for the cluster module, what matters is that when we do this with the cluster module, we want to wait and basically probe all of the peers to make sure that all of them are actually updated to the latest version of the schema before running any query, because otherwise you might actually fail. So some basic queries, right? So we have we just have an insertion up here with the binding of the values. We can see we have 3 values, and one is a UUID. So because of this binary protocol, you need to serialize a lot of types that are not scalar types in Lua, or not native types. So strings and number are okay, so we can infer them and just directly convert them to the right CQR format. But for UUID, we have to like write some, some serialization function that basically make it so that this UUID will be converted to a CQR binary format UUID. So when we execute a query, we can just retrieve a list of rows. And we have support for named argument too, so that instead of having to have an array, we can also just say age, which is here, is 42. Instead, otherwise I would have just an integer indexed array, which is not so friendly when you have a lot of arguments to bind. So our return value will be just a page basically, so a list of rows. And if there are more pages, you can actually use an iterator, so a Lua iterator that is built in the library. And so you can basically do 4 rows in client.paginate, and you write your query, and you're going to iterate over all of your rows automatically out of the box. So it's also a nice use case. I don't think it's included in here, but with a cluster module, the usage is exactly the same. So it's very easy to switch from the client to the cluster module. Only the cluster module is only supported in OpenResty to have all those nice things like load balancing, and I'm going to talk about it later. So those are the same queries, and we get the same result, except that here we have a lot of things going on under the hood. Yeah, support for authentication, like I said. Where the password authenticator is like the most popular way to authenticate with your cluster, so you can just specify your user password. For all production needs, that was also very important to have, as well as SSL, but SSL is actually under the hood. When you create your cluster, you can just specify SSL true and your server certificate. So the policies, so those are really important. We have different types of policies. So we have a retry policy that I did not include here because it's actually under the hood. It's just going to retry some failed queries a few times on different nodes, and that is kind of configurable. But the load balancing and the reconnection policies are, I think, a little bit more interesting. So what we have here is we require our cluster module, and we require a data center aware round-robin policy. So we have two policies currently supported, and I would love to add more. Maybe I'll talk about it later for some possible contributions. But round-robin is going to be just a dumb round-robin over all the peers in your cluster. But if you have multiple data centers, you don't want a request to go to, yes. Sorry to put you through this again, but so if your client is here, you don't want this client to start talking to another over here, because otherwise you're going to have cross data center traffic. So you'd rather ensure that you're always trying first to talk to those nodes here, and then if all of them are done, and only if, then you go to those nodes over there. So you just basically have to specify a load balancing policy, and the modularization of this is, I think, a big factor in improving this library, because now we can implement new policies just by implementing one new module. And that's kind of what I want to do for PUC-Lua implementation, but I'm not so sure yet to be able to specify what type of socket you want to use, Lua socket or a co-socket, but maybe later. So so the reconnection policy is going to behave in the same fashion. So we basically just require a module, and we can implement any type of reconnection policy. And this is an exponential reconnection policy, meaning that we start, if a node is marked as a failure, so if it's actually down, we're going to try later to reconnect to it, because maybe it's going to be back up, maybe your SRE will actually start it again. Maybe you're going to have your cluster is maybe self-healing. So we're going to retry first in 1 second, and we're going to exponentially increment that counter until we reach a maximum of 60 seconds. And if we reach a maximum of 60 seconds, then we only rarely try to reconnect to that node, because apparently it's really in a bad state. So yeah, the idea was to make this very, very simple to use for anybody who needs to talk to Cassandra. So the biggest problem is the interoperability between PUC-Lua and OpenResty. PGMoon, which is a popular driver for Postgres, has an implementation of an interoperability module between the co-sockets of OpenResty and Lua socket. So I kind of took that idea and improved it a little bit to make it so we can externalize it and use it in any library, in any type of driver or anything, so that in the future, if we want to build a library for OpenResty, we can also support plain Lua, PUC-Lua. And I used to say PUC, and I didn't know you. So anyways, I learned that today. So this library means that you can code your driver or your library in any way you want, and it's just like in one way, and you're going to support all of the box, either OpenResty or Lua socket. So you automatically fall back to Lua socket or LuaSec if you use HTTPS. So maybe a thing to explore in the future a bit more. Like Hisham said, like you have a lot of compatibility modules available in LuaRock, so this one is. In terms of testing, a few of the tools that were already presented to you. LuaCheck for static linting, Busted for the test Nginx for the integration test inside of OpenResty. It's a pure test engine written by OpenResty for testing OpenResty. and lua-cov, which is just our coverage module. So we test this library over Lua 5.1.5.2, not 5.3, because there are just too many compatibility issues. So for now, I didn't want to deal with it. LuaJIT 2.0, 2.1, and then we have our integration test with a different version of Cassandra 2.1, 2.2, and the most recent, which is actually 3.10, I think. And documentation. So documentation is generated with LDoc, which was also presented to you, which is very nice. I really like it. So you can, see the different modules that are available for you to implement your solution with this driver. So now, just to conclude, we can talk a little bit about this difficulty of maintaining code. So for Lua and LuaJIT, yeah, but now if we also add OpenResty into the mix, it just becomes a nightmare. Those were supposed to be hidden, so sorry. Okay, so yeah, so the idea is that it's already very hard with the language, so you have those incompatibilities between, so like we already mentioned, table.unpack, or you also have a table.new in LuaJIT, which is a very nice pre-allocator that basically creates a table with a pre-allocated number of slots in the hash or in the array part of your tables. So you save a lot of table rehashing, which is very nice for the serializers, the binary serializers. So if I have a value like, say, a list in Cassandra that has 100 arguments, and I want to populate it, I'd rather have it already have 100 slots, because I know that's the number of slots I'm going to use in my table. So it requires a heavy test suite. Poor Travis has been like crawling under like all the loads and stuff. It's just a little bit heavy to run, but some good things. So I really wanted to highlight that modularization really helped, and that was already highlighted as a good solution to this interoperability issues. I also really want to say, if you maintain a library for Lua or OpenResty, I think it's really important that you consider the needs of the people that are going to use it. Otherwise, they're going to make their own version. And again, that's exactly the issue we talked about. You end up with disparities in the fragmentation of the ecosystem. So ideally, the good thing about this driver is that it follows the data stacks driver. So there is a lot of guidance of that's how they do things, and just to stay aligned with what they do is easier than if you have too much freedom. So to support the cluster awareness in plain Lua, I think we could also just take those those lessons learned about modularization, because we already have modularized load balancing policies that we can reuse. We already have modularized authentication schemes. So we could implement a cluster-aware version of the driver that you just need to specify with which socket library you want to use. So Lua socket or Lua HTTP or OpenResty. And that would be, I think, really nice. Otherwise, I think I might also consider just dropping support for plain Lua, because I don't know, it's just a lot of work, and I'm not sure if there is a use case for Cassandra in plain Lua, because it's more a database that I think is mostly useful for those web servers and Kong especially. So if you have a use case for using Cassandra in plain Lua, I would love to hear about it. Otherwise, I might just do that. Okay. Okay, so that's it. We're hiring, so if you want to work on OpenResty, on Lua, on Kong, we have a jobs page with just positions that are available, and we really welcome contributors in both Kong and also the Cassandra driver. That would be really nice. That's it. If you have any questions.
Hi. I actually have two questions. Yeah, the first one is regarding, I think we discussed a few times in here the connection between Lua and games, and since now you're talking about a driver for Cassandra, do you have any idea about games using Cassandra on their structure, and If not, do you foresee this being used in the future, since there are a lot of game engines that use Lua? And the second question is about, you mentioned that you used SSL connections. Have you done this directly from Lua, or did you use the Cassandra or whatever?
Okay, the second question maybe is a bit faster to answer. So the SSL connection is handled by OpenResty, but it's only so there is encryption, but it's only a server verification of the server certificate. There is no client certificate support, although OpenResty is working on it. And for LuaSec, that's the fallback when we are not in OpenResty. It's handled both client and server certificates.
Cool.
But yeah, the trick was to support those two cases, and that's why this interoperability library, like this compat library, basically. And so for Cassandra in games, I think has a lot to do about just, I mean, it's really common, but just using the right tool for the right job. So like, I guess if you have some sort of distributed game that has that happens like around the globe or something, or maybe, but I think you need something a bit. You need protocols that are maybe a bit faster than just putting things in the database. But because you probably want some peer-to-peer communication between the different players. But for example, I could see Cassandra being useful for analytics around that game. So if you want to track the usage of that game, if you want to, I don't know. I've heard like some other projects and companies doing games where they track the movements of the players around the map, and they want to detect cheating if they see that players are just being a little bit too good or anything. And Cassandra could be a good use case for that, because it's a very, very efficient write-heavy database. So it's extremely optimized for heavy writing. So if you have a lot of data to write at once, but you're not sure when you're going to read it, and you're not sure, and you know that when you read it, you don't care so much about performance, you just need to read it at some point, it's a very good candidate.
Cool. Thanks.
Okay, Mike?
Hey, great talk. We were wondering here, when you mentioned about Lua 5.3 support, because for us, our impression was that 5.1 to 5.2 was much more of a change than 5.2 to 5.3. So what were the problematic parts?
I think it was me being too lazy. I think you're right. I think 5.1 and 5.2 was already like kind of painful, and I wanted to also add 5.3, and I was like, no, yeah, you're right. It's probably easier, but I just didn't deal with it. Oh, it might also be because LuaSocket or LuaSec, I think one of the two is not compatible with 5.3. LuaSec, okay, yeah. But I think they've been working on it. I'm not sure if it's complete, but if it is, I'm still a bit lazy anyways to actually do it now. Okay.
Hello.
Hi.
It's not something programming language oriented, but why the name Cassandra?
Why the name?
Cassandra.
I can tell you why Kong, but I cannot tell you why Cassandra. Actually, I think I can. Do you know the answer? It has to do with the mythology behind the character. Cassandra is, she sees in the future, I think. No, yeah, she's the oracle. She's the PD. But no one believes her. Yeah. Okay. Yeah. The PT or something like that. Yeah. Okay. I don't know the English word for it. Sorry. Yeah, that's it. Sorry. Okay. Thank you.